So let's do an example. Let's do an example um, of a problem with the dot product. So suppose suppose u equals the vector 2, 3, 4, and v is the vector 0, negative 1, 3. Um, so the first problem, find u dotted with v. So let me just point out that for this type of a problem, just to find the dot product, given the vectors in their component form, is probably not the easiest thing to find the magnitude of u, find the magnitude of v, multiply them, find the angle in between. I don't honestly, you know what? I don't really even know if it would be a nice way of finding an easy way of finding the angle between these two vectors without knowing what the dot product is in the first place. So we just stick to our regular formula that has nothing to do with the angle in between. That's just awful. Um, so u dotted with v, we use the regular formula, the one that says, whoops, sorry about that, that we multiply component-wise and then add up. So it's 2 times 0 plus 3 times negative 1 plus 4 times 3. So this, of course, is 0 minus 3 plus 12, which is nothing. Okay. And so what could this mean physically? Well, if we had a force in the direction 2, 3, 4 from the origin, so let's draw it. So this is the x-axis, y-axis, z-axis. Okay, so what we'd have is suppose we had a force in the direction 2, 3, 4. 1, 2, on some object. Okay, so the object is sitting at the origin, and we exert a force on it in that direction. And after exerting a force on it in that direction, it moves in the direction of 0, negative 1, 3. It actually moves that far. It doesn't, not just in that direction, but it actually moves that far. So 0, negative 1, 3. So 0 in the x direction, negative 1 in the y direction, and then 3 in the z direction. 1, 2, 3. So we consider u to be the force, and then the distance r to be the vector v. Then what would this dot product represent? It would amount of the work required to do that. It would be the amount of work done on an object in exerting a force on it, moving it in that direction. Yeah. Thank you.